we are discussing transformers and how they fail and what leads up to it. And I guess my first question is, everybody seems to be looking at ways of sensing partial discharge. Now, what exactly is partial discharge, and why is this of concern?
Okay, partial discharge is a incomplete arcing of the insulation paper, and what it starts with is random defects that occur in the paper because nobody can manufacture a perfect, cellulose paper, and at high voltages, and there will be pathways digging further into the paper and then weakening it. So the effective thickness of the paper will be reduced.
Okay. And
by the way, beside partial discharge, once the arcing occurs, the cellulose actually will be broken down. And this creates a whole bunch of different gases. And the industry is very fond of using a dissolved gas analysis, which is by sampling of the oil and look at the content and find out analytically how many species are present, and then they do a very elaborate ratio, and from there they diagnose the nature of the partial discharge, whether it's a air bubble or moisture, or it's the cellulose paper. But again, this is not physical location. They understand more about the nature. This partial discharge are related to dissolved gas analysis, and in fact, dissolved gas are caused by partial discharge. So they are complementing each other, but it's not giving enough diagnostic information.
But this is something that's done periodically, right? It's not something that's real time. They'll just sample it once a year, or.
Well, actually, it is a part of a trending. You see, just like you go to a doctor for an annual checkup, but if you have been known to have some physical ailment, like your heart has potential problem, then the doctor may want to see you every 3 months. So it depends on the user. What you got as a first measurement will indicate to you what frequency you should check yourself.
Okay, so they're essentially sampling the oil in the transformer, and then as they see a problem arise, they're doing more sampling so that they can sort of catch it before it fails.
Yeah.
Is there any real-time way of sampling the oil to see indications that you're going to have a problem?
Yes. There's now online dissolved gas analysis equipment, but quite expensive, and it's still an incomplete picture because dissolved gas is a cumulative event. That means something had occurred and then resulting in a gas mixture in the oil that exists on day XYZ. But when, you don't know. And so,
is there anything else in the oil which could indicate that there's a problem building up?
well, actually, it's a good question. Moisture is the one that will induce the partial discharge because moisture make it easier for the high voltage to create arcing. So typically you will have air bubble but have moisture impregnated. That will accelerate the incidence of partial discharge.
Okay, so you can also sample for water, and that will actually indicate before the partial discharge happens.
Not quite, because again, by taking a sample of the oil, is all historical. So at some point there is some moisture, and then it occurs, but there is no direct correlation. And the moisture, your question give rise to another industry practice that is challenging. In dissolved gas analysis, when they sample the oil, they also test for moisture. They can do that.
Mm-hmm.
But again, this is not very precise. So the problem is in a transformer, the oil is recirculated constantly, and the winding is carrying high current, so there's there's heat generated. And the recirculating oil arrange a temperature profile. Typically, you will have higher temperature at the top of the tank, and then lower temperature at the bottom of the tank. It's most convenient to sample the oil at the bottom of the tank, but unfortunately, it's good for dissolved gas analysis because the oil, will be uniform throughout. But temperature being different, that means the amount of moisture, a different portion of the oil might be different. The assumption that we make that the temperature of the oil is being the same is not correct.
Okay, so essentially, the higher the temperature of the oil, the more the humidity is absorbed into the oil. Is that correct?
Yes. It's something to do with the solubility of the oil.
Mm-hmm.
Okay. Now, actually, behind this, there is a reservoir of moisture inside the tank. You know the transformer is constructed with pressed wood columns and board, holding the whole winding stack. These pressed wood are rich sources of moisture.
Oh.
And so are the cellulose paper.
And is there any way of actually sensing within the transformer, like in the cellulose, in the pressed wood, if there's moisture coming out of there?
So far has been very difficult because the extent of the technology is that they have to sample the oil.
Mm-hmm.
And even today, there are electrical methods to measure moisture, but online, but it involves a probe sent into the transformer tank at the bottom. So it's still sensing the flow, and it's not sensing close to the culprit, the cellulose paper or the pressed wood. So people have been struggling for a long time, and they realize that the moisture transport is a dynamic process, but they have no tools.
And I understand you're coming up with some tools to research
exactly
this area.
Yes. Actually, it's a fiber optics sensor that can sensing moisture. See, moisture sensing must also measure temperature, because they are interrelated. So fiber optic nicely fit into that requirement. One sensor coated with special material to sense moisture. Another sensor, fiber optic sensor, senses temperature, which is natural.
And I guess it being fiber optic, it doesn't have any issues with the high voltages.
Yeah, I understand that these days transformer voltages are going higher and higher because at higher voltage the grid, transmission has less loss. So it's not unusual to have 800,000 volt networks being built, and only fiber optics can meet such a requirement.
Wow.
Yeah.
And so this is something that is in place, and you can actually, the sensor works like 24 hours a day.
Yes. We have all benefit from telecom, right? And fiber optic has helped a lot to bring down the cost to a few cents per minute. And the same fiber optic made with glass will now serve this purpose. And they have 25 years of life.
Wow.
Yeah.
Okay, so the life of the sensor is comparable with the life of the transformer.
Yes, yes.
Okay.